Let's solve few problems based on the Rolle's theorem and mean value theorem. All right. See the first one here. Verify Rolle's theorem for the function f of x given by that. Right. So first, what we do, take f of x. F of x is equal to x square plus 2x minus 8. So here it is given x belongs to minus 4 comma 2. Now what are the conditions for the Rolle's theorem? First one is f is continuous in minus 4 comma 2, correct? So the first condition what you can say is f is continuous in minus 4 comma 2, and second is f is differentiable in 4 comma 2, and third one is there exists c which belongs to minus 4 comma 2 and f dash of c is equal to 0, correct? If these three conditions are satisfied, then we can say that Rolle's theorem is satisfied, or you can say that verification of Rolle's theorem is done, right? So first what we do, will show that it is continuous in minus 4 comma 2. Now it's a polynomial function, correct? Since it's a polynomial function, you know that all polynomial functions are continuous, isn't it? So the first part of it is done. So what we can write, since f of x is a polynomial function, f of x is continuous. F of x is continuous, correct? Now after that, f is differentiable. Let's try to find this one out now. See what we have. F is differentiable, correct? Differentiate this one. F dash of x is equal to minus, so 2x square, which is 2x plus 2. Now 2x plus 2, that means f dash of x is differentiable, and that too it is differentiable at minus 4 comma 2, correct? Substitute, that means f dash of minus 4 is going to become minus 8 plus 2 is minus 6, and f dash of 2 is nothing but 4 plus 2 is 6, correct? 2 into 2 is 4, 4 plus 2 is 6. Make sense? Now what we do, so we have these two values. Second condition is also true, that is f dash of x is differentiable at minus 4 comma 2. Now the last one, there exists a point c, correct? We need to find that one out. So let's do this one. See, f dash of c, correct? So f dash of c becomes 2c plus 2. This is equal to 0. So 2c is equal to minus 2, c is equal to minus 1. See, minus 1 belongs to minus 4 comma 2, right? So c belongs to minus 4 comma 2. So what do we have now? We have a problem, we have a question or a function which satisfies all the conditions of the Rolle's theorem, all the conditions, isn't it? So what can we say? Rolle's theorem for the function f of x is verified. Understood? So let's do the second question. See the second one, we have a function f from minus 5 to 5 to r is a differentiable function, and if f dash of x does not vanish anywhere, prove that f of minus 5 is not equal to f of 5. Alright, fine. So for this one, what do we have? We have a function f from minus 5 comma 5 to r, correct? Now remember, they have not given you what is the function. The function can be anything, isn't it? So but what we do know is that first and foremost it has to be continuous. So we can say f should be continuous in minus 5 comma 5, and f is differentiable in minus 5 comma 5, correct? And the last one, f dash of c is 0 and C belongs to minus 5 comma 5. So this is the condition, correct? So first what we'll do, f is continuous, well and good. So this is fine. This is also fine, but this is not fine because they're saying f dash of x does not vanish anywhere. If it was 0, then would have told it would have vanished. Since it's a non-zero value, so what do we have? F dash of c. So f dash of c, which is equal to f of b minus f of a divided by b minus a. If this was 0, then f of a is equal to f of b, correct? But since this is not equal to 0, since this is not equal to 0, f of b minus f of a is not equal to 0. Only when the numerator is 0, the value becomes 0, isn't it? So now what do we have? If you take this, f of minus 5 minus f of 5, correct? So f of minus 5 minus f of 5 is not equal to 0. Or b value in our case is actually, this is going to be plus 5, this is minus 5. So transpose. So if you transpose, what do you get? F of 5 is not equal to f of minus 5. See, we just proved that. See, the whole point of the problem and the most important part of the problem is this. Okay, because it is a non-zero value, the numerator is non-zero. So f of a is not equal to f of b. Or in our case, we can say that f of 5 or f of minus 5 is not equal to the other value. Clear? Now, let's do the third question now. See the third question. Here we are dealing with mean value theorem, right? See, verify mean value theorem if f of x is equal to so much in the interval a comma b, where a is 1 and b is 4, right? Okay, so f of x, x square minus 4x minus 3, a is 1, b is 4, right? So these are the values, f of x, a and b. Now what we are going to do is that first let's try to understand what are the things we have. First, f of x should be continuous in a comma b. It should be differentiable in a comma b. Then f dash of c is what? F of b minus f of a divided by b minus a, correct? So we'll look into that one. So very first part is, it is continuous. Yes, it is continuous because it's a polynomial function, correct? So we say that f of x is a polynomial function, or f of x is a polynomial function. So what do we have? F is continuous, correct? So it's continuous. It's also differentiable because if you differentiate, you're going to get 2x minus 4, which is again, it's a differentiable function, correct? Now comes the last part, that is f dash of c is f of b minus f of a by b minus a, correct? So substitute f of b minus f of a by b minus a. So f of b is going to be 4 square minus 4 square minus 3 minus of f of a value is what? 1. So which is going to be 1 square minus 4 minus 3 divided by b minus a, that's 4 minus 1. See, 4 square and 4 square cancels out. So you have minus 3 minus, this is going to be minus 7 plus 1, which is minus 6. 3. So minus 9 divided by 3 is minus 3. Correct? So what we have, minus 9 by 3 is minus 3. This is f of b minus f of a divided by b minus a. correct? So what did we do just now? We calculated the value of f dash of c, isn't it? Now c has to be a value which is in between a and b. Makes sense, correct? So now what we are going to do now is we prove that c exists between a and b. All right, let's do that one now. See, f dash of c becomes c square minus 4c, but this value is minus 3, isn't it? So what do you get? C square minus 4c plus 3 is equal to 0. So can we write this as c minus 3 into c minus 1 quadratic? So what do you get? C is equal to 1 or c is equal to 3. Now if you look at this, both the values, that means c belongs to 1 comma 4, correct? So we cannot take the value of 1, so we have the value of c is equal to 3. So even though 1 is present, 1 cannot be taken into consideration. So what do we have? 3 is the number which is between 1 and 4, isn't it? So between 1 and 4, we have the value of c. So this proves the mean value theorem. Fair enough? Let's do the next one. See this problem. So what you have is f of x cube minus 5x square minus 3x. Again, it's a polynomial function, isn't it? Here, a value is 1, b value is 3. Now, the question is a little different. Find all c value for which f dash of c is 0. Find all the value, isn't it? So, first we need to prove, verify it. Now, it's a polynomial function. Since it's polynomial function, it is going to be continuous. Correct. So, the first one, it's a polynomial function. Since it's a polynomial function, wherever you go, it is going to be continuous. After that, it is differentiable, correct? So it is a differentiable function. Differentiable function. So the third one is, this is where it's important for us. Okay. So first what we'll do, f dash of c, f of b minus f of a by b minus a. So f of b, remember b value is 3, correct? So if you substitute, so you are going to get 3 cube minus 5 into 3 square minus 3 into 3, correct? So you are going to get 27 minus 45 minus 9, isn't it? So if you take common here, so 9 into 3 minus 5 minus 1. So 3 minus 5 is minus 2, minus 2 minus 1 is minus 3. So we'll get 9 times 3 minus 27, correct? F dash of c is this. But the question says, find all c which belongs to 1 comma 3 for which f dash of c is 0, isn't it? So here, when we are trying to verify first, what you need to put, see that minus 27, just like the previous problem, we need to solve and get the answer. All right. So let's solve this one. See, f dash of c, 3x square minus 10x minus 3 is equal to minus 27, correct? Or 3x square minus 10x plus 24 is equal to 0, or x square. So this is going to become, oh, we cannot take the 3 common here because you won't be able to get the answer. So we have a 10, correct? So you can't simplify this. So 3x square minus 10x plus 24, 3 times 24, 24 into 3, this is going to give me 72, correct? 72, split the term, which you should get it as 10, correct? So you can do by 12, no, you can do by 8, Since we can't find out the proper way, so what you do, just apply the formula. See, if you're applying the formula, x is equal to 10 plus or minus root of 100 minus 3 into 24 divided by 6. Correct? 10 plus or minus root of 100 minus 24 times 3. 24 times 3 is 72 divided by 6. 10 plus or minus root of 100 minus 72, which is going to give us 28 divided by 6, or 10 plus or minus 2 root 7 by 6. Numerator and denominator you can divide by 2. So what do you get? We take 2 common in the numerator. So you are going to get 5 plus or minus root 7 by 3. So when you have 5 plus or minus root 7 by 3, so you have two values, plus root 7 by 3 and then minus root 7 by 3. Correct? So 5 minus root 7 by 3 is going to be a value between 1 and 3. So mean value theorem is verified. But the other part, for all the values you are going to get 0. Correct? So that we need to do now. Alright? Second part, see, find f dash of x or f dash of c in our case. So you'll have 3x square minus 10x minus 3 or 3c square minus 10c minus 3. So equate this to 0, right? Multiply. So 3 into 3 is 9. 9 in the sense you can take 9 and 1 itself. Isn't it? Minus 9 minus 1 you can take. 3c square minus 9c minus c minus 3. This is equal to 0. But if you do this one, 3 into minus 3 is minus 9. Minus 9 will not give you this one if you look at it, because here the values will not suffice. Isn't it? So what you do, you apply the formula again. If you're comfortable, just apply the formula. Alright, so if you apply the formula, then you're going to get c is equal to 10 plus or minus root of 100 minus into minus plus 3 into 3 is 9. 9 plus 4, 36 divided by 6. Correct? So now what do we have? 10 plus or minus root 136 divided by 6. Now, if you're doing by 136, 136 is not a perfect square. Definitely, you can just keep it as it is. So what are the values of c now? So we have two values of c. So the first value is 10 plus root 136 divided by 6. Second is 10 minus root 136 by 6. So these are the two values of c, where f dash of c is going to give us 0. Clear? So these are all the different types of problems what you get in mean value theorem and Rolle's theorem. So in the next one, we'll look into the next part of this particular chapter.